Assalamu alaikum. Hello everyone. My name is Imran and I am a PhD student from China University of Petroleum. And my topic is experimental study of polymeric microspheres and Guar gum as chemical additives to recover the residual oil from the reservoir. Here are contents. Number one, background and objectives of research. IFT, interfacial tension test. Number three, experimental setup. Number four, experimental procedure. Number five, enhanced oil recovery. Number six, water cut percent versus oil recovery. Number seven, conclusions. And number eight, references. In overview, petroleum has remained the most highly used source of energy in this modern world. The demand for this source of energy keeps increasing yearly. The spiking demand has placed a tough goal on the industry players to meet the demand for the petroleum for various purposes. Industry's reaction towards the demand, huge sums and budgets have been placed to search for new technologies and chemicals to maximize production from the various fields. And currently available solutions are: number one, improved oil recovery methods such as extra wells and drilling, perfect completions design, intelligent completion system, etc. Number two, EOR, chemical methods, steam injection, etc. In our case, we will use EOR methods, especially chemical methods. On the left side, this is a general view of energy consumption in the world. The commonly used methods are: number one, mechanical methods, chemical methods, and number three, microbiological methods. For the sake of this research, attention will be directed towards the chemical methods. As I told you before, that we will use chemical methods, and in chemical methods especially we will use suspension flooding. And on the left side, these two figures are showing injection well and production well, having two different layers, high permeability layer and low permeability layer. Low permeability layer is represented by low K, and high permeability layer is represented by high K. So our main purpose is to displace the oil from the reservoir, especially from low permeability layer, which is difficult task, and we are doing this task with the help of suspension flooding to displace the oil from low permeability layers. Chemical methods involve different ways, like in situ gels, number two, monomers, number three, preformed gels, number four, microgels, number five, viscous systems or RPMs, number six, polymer gels. In our research, we will use polymer gels and we will use nanosuspensions as a chemical methods to displace the residual oil from low permeability layers. Objective of the research: number one, design and formulate a suspension particle gel. Number two, characterizing the formulated suspension particles to improve the retention of particles in porous media and to identify its distinct properties. Number three, testing the suspension particles as conformance control. Here is interfacial tension test. Actually, in petroleum, low IFT is the best choice. So we are testing different chemicals, and we are just identifying that which chemical is producing lowest IFT. So we used different kind of nanosuspensions like HP 500, HP 1000, HP 3000, and nanosuspensions of white bottle. So we compared the IFT of these nanosuspensions with the pure water IFT. Pure water IFT has value approximately 25, and all the nanosuspensions produced lowest IFT as compared to pure water. But among these all nanosuspensions, the white bottle nanosuspensions produce the lowest IFT, which is our best choice for petroleum industry. So we are using these nanosuspensions for further tests in sandpack tube. This is the equipment of sandpack. Sandpack is used for displacing oil. Sandpack tube is packed with different sand size. In our case, we use sand size of mesh 120. When sand is filled with the sandpack tube and saturated with water and oil, and then we injected different chemicals in the sandpack tube, and tested the different parameters of this experiment. Experimental procedure involves water flooding experimental procedure. Number one, sand pack preparation, saturation of the sand pack with water, saturation of the sand pack with oil, first water flooding, chemical flooding, and second water flooding. Here are the experimental steps. All the steps are explained in detail. So it's difficult to explain deeply because due to limitation of time, I want to skip to explain all these steps one by one. I want to go to explain my results. So these are just the experimental steps, how we did experiments. Here is the result of our sand pack experiment. On y-axis, we can see oil recovery percentage, and on x-axis, there is a pore volume. And there is, this is the result of polymeric microspheres flooding. We can see that oil recovery is continuously increasing. In the middle of this curve, you can see a green patch and a orange color patch, and these different patches are showing that the green patch is showing the first half injection of nanosuspension, and the orange patch is showing the second half injection of nanosuspensions. During these nanosuspension injections, oil recovery continuously increasing, which is the best one and which is our good result. So it means our nanosuspensions did a good job. Here, polymer gel, these two different graphs are showing the comparison between polymer gel and nanosuspensions. In polymer gel injection, the residual oil or remaining oil in the reservoir is 32.21%, and on the other hand, the residual oil or remaining oil in the reservoir is 12.21%. It means nanosuspensions injection did a good job to displace the oil from the low permeability layer of the reservoir, and mostly the oil is displaced or produced from the production well, and only a few amount of oil is left behind in the reservoir, which is about 12.21%. On the other hand, the polymer gel injection is not so effective as nanosuspensions injection was. So nanosuspension was the best chemical injection. Here is the comparison of oil recovery percent versus water cut. In petroleum industry, this is the basic problem or the basic requirement that water cut should be reduced during the production of oil. So in our case, we can see clearly that the water cut was reduced and oil recovery was increased effectively, which means that our chemical did a good job to displace the remaining oil from the reservoir in the low permeability layer, and also reduce the water cut percentage. So the conclusion of our experiment was that number one, during gel injection, it was observed that the injection pressure for nanosuspensions was much higher than the injection pressure for polymer gel, which indicate that nanosuspensions cannot be injected easily as the nanoparticles swell in water and increase their size, due to which during injection pressure increased much faster than the polymer gel injection. Number two, as a result of slug injection, injection pressure for nanosuspension was much higher than the injection pressure for polymer gel injection. But during second water flooding, most of the nanoparticles were flushed out through outlet, due to which injection pressure for nanosuspension dropped during second water flooding. Number three, during second water flooding, injection pressure was still much higher for nanosuspension flooding than injection pressure for polymer gel injection, which indicates that during second water flooding, nanosuspensions were not completely flushed out through outlet, while few particles were trapped into pore throats and did not propagate so fast. And these particles did a good job to plug these zones and diverted the water flow towards low permeability zones and increased the sweep efficiency. As a result, enhanced oil recovery is improved as compared to polymer gel flooding. Number four, moreover, nanosuspensions reduce the water cut percent very effectively as compared to the polymer gel flooding. Here are some references And thank you for listening my PPT. Bye bye.